Number 2 says the quarterback of a football team averages 110 passing yards a game with a standard deviation of 20 yards. Let's identify those two numbers there. Average is 110, standard deviation of 20. And the question is saying, how likely is it that he's going to throw for more than 150 yards, let's say in the upcoming game? Well, if his average is 110, so we already got a curve there, so let's mark it. So we're saying that his average is 110. So here's our average. And there's a standard deviation of 20, right? So this tells us some games he throws more than for 110, some games he threw less than 110. So standard deviation gives us an idea of kind of that variability. So if we go out, let's just kind of mark off our curve here. So standard deviation of 20 means we're going to jump 20, so we've got 130. Another standard deviation gives us 150, which is actually the number we're looking for. And then 3 standard deviations, another 20 out would be 170. Right? If we go the other direction with it, so let's just mark it off here. So we'll go 3 standard deviations out to the left. And again, what we're using here is that we're using, let me kind of steal something from the last problem here. Copy this over. Right, so if we use what we looked at in that last problem, right, our 68, 95, 99.7% rule here is that we can get an idea of most of the time our quarterback throws in between, what 2 distances. Well, that's what we want to figure out. So let's go, remember, we're going plus 20. Think your standard deviation is a plus or minus here. So we're going plus to the left or to the right, and we're going minus to the left there. So if I subtract 20, I'm going to be at 90, and then 70, and then 50. Once you get it labeled, then it's easier then to kind of go back and take a look at what this means. So 99.7% of the time, our quarterback threw somewhere between 50 yards per game and 170 yards per game. 95% of the time, he threw between 70 and 150. 68% of the time, he threw in between 90 and 130. So the question is saying, how likely is it going to be that he's going to throw for more than 150 yards? Well, more than 150 yards, there's 150, so we're saying, what's the probability, what are the chances that that's going to happen? Well, remember, the thickest or fattest part of the curve is what's more likely, and then it becomes more and more thin. So just by eyeballing it and kind of looking at it right here, we could probably say, well, it's probably not going to be very likely that he's going to throw for 150, because that's just a little bit further past where he usually throws, right? So 68% of the time he's in between 90 and 130. So this is where he is most of the time. So that's a little bit of a stretch. Not to say this is impossible, but a little bit of a stretch. Well, more than just eyeballing it, we actually want to come up with a way to get exactly what that percentage is. There, 5% chance, a 10% chance, a 1% chance. So we want to come up with something a little bit more precise. And so that's where we have what we call our z-score, or our standardized value. So what we're going to do is that we're going to compare the number that we're looking for, which is 150, to what it usually does, right? And then this is going to tell us, we're looking for the area, how much of this section right here, is that 1% of this whole chunk? Is it 5%? So we want to know, because remember we said that this, if you do half of the curve, like what we did on the last problem, half of the curve is 50%. Right, so what would this little sliver out there represent? Well, you could probably guess it's going to be a small number, but let's figure out exactly what it is. So our z-score here is that we're going to take the number that we're looking for, which is 150, and we're going to subtract the mean, which in this case is another notation for mean is x bar, but also we're using the mu notation here. So our average is, or our mean is 110, and then our standard deviation, which in this case they tell us is 20. Another way that you might see this, kind of a shorthand notation for this, is that we can write this as our mean, and then our standard deviation. It's almost kind of like when we write a point like x comma y, we can write this as a shorthand of that we have a mean or an average of 110 with a standard deviation of 20. So if we, kind of crank out our numbers here, 40 divided by 20, right, which gives me 2. And by the way, what the z-score is telling us is that it's telling us how many standard deviations away is the number we're looking for. Well, 150, we actually is exactly 2 standard deviations out, so that's where that number 2 comes from. Now, what I want to do is then I want to say, well, what percentage of the graph does that represent? So that's where we have to go to a table. This is the table that's in the front cover of your book. I'll also just kind of pull up a website. If you Google standard normal probability, you'll get a table that looks something like this. And what these numbers give us is they give us the area underneath the curve, but it's always to the left of that point. So what we're actually going to be finding here is we're actually going to be finding this section. Let me kind of highlight this. Is that it's actually going to tell us how much does that part of the curve represent. Well, again, half of it, the halfway point is 50, so you could maybe kind of think 70, 80, 90. So the area to the left is going to represent a majority of the curve. This is a tiny, and we're kind of maybe even kind of exaggerating what that really looks like. Just a tiny little sliver out there. So what we do is that if we go to our table and we look for 2 standard deviations, and let me zoom in a little bit on this. So if you notice, for 2 standard deviations, we get 0.9772. So what that's telling us is that 2 standard deviations represents almost 98% of the graph, right? Because remember with the decimal, you have to slide it over 2 places. So a z-score of 2.0 translates to 0.9772. So this translates to 0.9722. 0.9772. And so if we convert that over to a percent, right, if we slide that over 2 places there, so it's approximately 98%. So what we're saying is that this part of the curve, so this point over, represents 98% of the curve. Well, if that represents 98%, if we subtract 1, that represents 2%. Right, this chunk right there represents 2%. So is it likely that he's going to throw for more than 150 yards? We could say that it's not likely because there's only, or at least we're predicting, a 2% chance that he will throw for more than 150 yards. Therefore, it is not likely to happen. All right, so go ahead and pause and try number 2 on the right side.